So in exploring how to get the number of bags at day 5, we found a really interesting pattern, which had to do with looking at numbers that were less than the stage we were at by 1, decreasing that by 2, and we had this great pattern with just going up by 2 for all possible things in the denominators. And the only trouble was we had to figure out some coefficients that needed to go in front of these binomial coefficients when we switched from one number of bags to the next. But we also saw something cool going on there, which was if we were focused on using this technique to determine the number of arrangements on day 5, the sums of the coefficients that go here needs to be equal to f of 4. So if we think that we've got a cool theory going on here, the absolute best next thing to do is to see if it will hold for just one more level that we could maybe visualize by hand. So let's try to take this one step further and see if our intuition holds or if we need to modify our thinking at all. So we're thinking that if we wanted to know the number of arrangements for day 6, we should have something that looks like this. Everything is going to have come from having 5 bags in the cupboard, 3 bags in the cupboard, or 1 bag in the cupboard. And then I've chosen an appropriate number of bags from what was there, even numbers. And what f of 6 should be is this sum, once we can figure out what these coefficients should be, i.e. the number of arrangements from step 5 that had 5 bags, the number of arrangements from step 5 that had 3 bags, and the number of arrangements from step 5 that had just 1 bag. So we're missing these coefficients. How do we find them? Well, we find them by the way that we just described them. How would I have gotten 5 bags on the shelf in the transition from 4 bags to 5 bags? Well, we saw that we could only get 5 bags by having 4 bags on the shelf and then selecting 0 of them to be put inside the one that we had on that day 5. How would we get 3 bags on the shelf? Well, here there are a couple of different options. Maybe we got 3 bags on the shelf by having 4 bags on the shelf and selecting 2 of them to go inside of the new bag. Or it's possible that we only had 2 bags on the shelf and we didn't select any of them to go inside that new bag. And lastly, something happens, how would we get 1 bag on the shelf? Again, in a couple of ways. We either could have had 4 bags and selected to put all 4 of them inside the brand new bag on day 5, or we might have had only 2 bags on the shelf and we selected both of them to go inside the bag that we brought on day 5. Now, each one of these situations translates really nicely into a binomial coefficient. 4 choose 0, a 4 choose 2, a 2 choose 0. These are all of the this is how many bags I had, and then I selected them. However, when we talk about maybe there were 2 bags on the shelf and I selected 0 of them, that is perfectly true, but there are more ways to have 2 bags on the shelf than there are to have 4 bags on the shelf. And so what I'm missing is the number of different ways there are to have just 2 bags on the shelf at this particular stage. And what we just computed previously is that there were 4 ways to have 2 bags on the shelf at that moment in time. Similarly, the 4 choose 4 and the 2 choose 2 are coming into this answer right here, but because there are more ways to have 2 bags on the shelf than 4 bags on the shelf, in fact there are 4 ways to have 2 bags on the shelf, we're going to need to multiply the 2 choose 2 by this 4, which is one of those weights that was coming from that picture. So altogether, if we plug these values in for A, B, and C into our equation, we should find that f of 6 should be equal to this sum given here, where our A, B, and C coefficients have something to do with the only way that we could have gotten this number of bags in stage 5. So when we're transitioning to having our 6th bag introduced, we either have 5 bags, 3 bags, or 1 bag in order to make choices with moving forward. And all we need to do is determine, well, how many different ways were there in the graph to have come up with 5 bags? how many different ways were there in the graph to have come up with 3 bags, and how many different ways in the graph were there to have come up with just 1 bag. And therefore, when we sum up all of those possibilities, we should get as the answer for f of 5, which we already had a different way, but this is a different way, but this is another way to come up with the solution. We do find that indeed f of 5 is the sum of the coefficients we need to determine how many bags there are at stage 6.